Timmy wants to kill the evil dragon by shooting foam bullets at it. He loves keeping it PG for everyone, of course. But in doing so, he needs to aim his projectile properly so it hits the dragon exactly in the mouth. Let's see how we can use our understanding of projectile motion to help Timmy kill the dragon. Timmy notices that when he aims the gun directly along the line of sight at the bullseye, which in our scenario is the dragon's mouth, the ball misses and hits a point at distance y beneath the bullseye. We need to figure out what vertical distance above the bullseye we need to aim the gun's line of sight at so that we can help Timmy kill the dragon. I have drawn a simple visual to show what the problem is asking for. This visual shows us the different launch angles of the gun as the gun creates a line of sight represented by the dotted lines toward each vertical distance above the bullseye. Understanding this is critical for us to help Timmy slay the dragon. Don't let Timmy lose by saying that this line of sight is the path of the projectile. That is wrong, and Timmy might even have to change his target if you say that. The projectile must go in a parabolic curve because gravity influences its motion. Also, don't be tempted to say that Timmy just needs to aim his gun at a vertical distance of y above the bullseye because that's all he needs to do to fix his error. That is also wrong because there are several kinematic factors, like gravity, that influence the motion of the projectile. First, let's use our understanding of vectors. The projectile is launched at an angle, so there has to be a vertical and horizontal component to velocity. If we increase the angle, the horizontal velocity decreases because of trigonometric ratios. We can then rearrange d equals vt to get v equals d over t, and we see an inverse relationship. As we decrease the horizontal velocity, we increase the projectile's time in air. Projectile motion is formed by vertical motion and horizontal motion, but the variable that connects the two is time. Since we know our time increases, we can then use our next kinematic formula to find vertical distance. Using this kinematic formula, we can conceptually solve for the vertical distance. We know that time increases and that the initial vertical velocity increases since Timmy launches his gun from an angle above the horizontal. This means that the vertical distance has to be a greater value than the y value that they've given us in the problem. It makes sense because the projectile spends more time in air and therefore needs more time to drop away from the straight line path along which it was fired. And there we go. The answer is C, that the gun should be aimed along a line of sight above the bullseye at a vertical distance slightly higher than y. We have successfully helped Timmy kill the dragon. If you follow what we have learned in this walkthrough, you can also be successful in answering these types of questions in the future.